and welcome to our presentation of Virtual Solar School 2020. I see some familiar names on our participant list, and I see a few new ones as well. So I want to welcome everybody. Just a reminder, this is our third presentation, and the previous two presentations have been recorded and are available on YouTube. And so we'll make sure that you have a link to that so that you can watch the other presentations if you happen to miss them. My name is Rowan Wyckoff. I'm a Solar 2 instructor, and my intent tonight is to present with you an overview of the curriculum that we go through in Solar 2, and to give you an idea of what to expect if you come to Solar School. So what we hope to do during Solar School is equip you with knowledge and understanding that allows you to bring electrical power to those in need. The picture on the screen here shows the Earth at night, and you can see that along the equator and in many areas of the world, it's very, very dark. A vast majority of the world, the day ends when the sun goes down. And it doesn't take a whole lot of power to make a big difference in a child's life, in the life of a school or a church. And we hope to be able to allow you to address some of those needs. So how do we do it? We teach basic electrical concepts. We don't teach you to be an electrical engineer. We teach systems that primarily are standalone systems. They do not connect to grid power or to a generator. The reason we do that is primarily for safety, but also because the complexity of those systems is much more than we feel like we could teach to people that are not otherwise electrically inclined. And also what we do is we give you we've shared experience that we've gained through multiple installations around the world. Our solar systems are located in, I believe we're up to 8, maybe 9 countries now around the world, and including Africa, Ukraine, South and Central America, and in Puerto Rico as well. And one of the most valuable resources we give you is a great handbook. Where Solar School is a 3-day experience, and it's hard to pack in everything you need to know in that 3 days. And so usually what we tell people is to come to Solar School and then go home and put your book away for about a week or two, and then pick it back up and read through the whole thing, and you'll be surprised at how much you understand and how much more information you can accumulate out of our book. A couple of things that we don't do. Once again, we don't make you an electrical engineer or a solar expert. That is well beyond our skill set. We do have electrical engineers and that level of training in our teacher staff, but I myself am a family physician. We have some people with little or no formal electrical training, and we feel that this is a system and a process that we can teach to almost anybody if they have a little bit of DIY capability. One other thing that we don't do, as I mentioned before, is we don't cover any system that uses or connects to another power source, such as the electrical grid or generator systems, and primarily this is for safety. So I want to take a few minutes and just give you an overview of a solar power system. This is all of the components that would go into a solar system that we teach to build at Solar Under the Sun. As we've mentioned in previous lectures, Solar Under the Sun is primarily a teaching mission, and our goal is to give you the information you need to form and lead a team to go install a system somewhere in the world. During Solar School, each component that we talk about tonight, we give a complete lecture on, and then you have hands-on experience in wiring those components together and ending up with a complete system. So if you look on our system now, you can see we've got our solar panels connected through an interface box, which is a disconnect. We come down to our load center, which is similar to the breaker box in your house. The charge controller is the smartest piece of equipment in our system and helps maintain our batteries. Our batteries down here, inverters convert DC electricity to AC, similar to what you have in your house and can plug into. And we can also connect to DC equipment as well. So let's start with the center of the system. The DC load center is the hub of the system. Any power that's gathered or used will go to this particular piece of equipment. It's very similar to the circuit breaker box that you have in your home. It allows circuit breakers to help protect our equipment, and it gives us a way to disconnect power in the need, if there's a need, whether that's due to maintenance or a safety issue. There are several different models that we use. The one in the bottom left here is what we use for our larger systems, and then the two on the right we use for our smaller family scale systems, and we've got two. The PV panel or solar panel is how we gather electricity. I always tell people that we don't need to know exactly how it works. We just need to know how to pick the right one and how to hook it up. And so basically it captures the energy of the light, converts it into DC voltage, which is similar to what you would get out of a battery. And one point to make is that the physical size of the panels is proportional to the amount of power that they can generate. So if someone's trying to convince you that a little tiny panel can power your whole house, that's just not physically possible. So our interface box, coming from the solar panels, before we get to the DC load center, we put in an interface box, and these are two that we use most often. They serve as a disconnect point. You can't turn a solar panel off. If it has sun to it, it's going to make electricity. And so this gives us a way to disconnect the power from the system so that we can do maintenance on it. It also serves as a point where we could connect more than one set of solar panels to allow a bigger system and give us room to grow. The charge controller is like I said, one of the smartest pieces of equipment in our system. And these are two on the right are what we typically will use. The smaller one on top for the family size systems, and the larger one for our larger systems. There are two different types. PWM stands for pulse width modulation. You don't really need to know exactly what that means, but what you do need to know is that they're less expensive, which is nice, but they're also less efficient. And we typically use them with smaller systems because losing a little bit of efficiency in a small system isn't nearly as critical as losing efficiency when we're dealing with larger amounts of power. Maximum power point tracking, MPPT, is one of the newest technologies, and what it allows the system to do is to figure out the voltage that the panels can operate at that gives us the most amount of power, and then it adjusts that energy that it collects and changes it to what the battery needs. By doing that, we're allowing both the battery side of the system as well as the solar panel side to work somewhat independently of each other, but at their peak performance. Once again, they're a little more expensive but more efficient, and so it's a reasonable trade-off as we're getting into bigger and bigger systems. Because if you start adding solar panels, then that increases cost as well. One of our key pieces of equipment for our operators in country is our battery monitor. This is primarily installed in our larger systems, our community-sized systems, and what it allows them to do is see the percent that the batteries are full. So we like this number up here when it's on battery percent full, 100%, or at least greater than 80. We prefer to keep the batteries at least 80% charged to maximize the life of the battery. The deeper that we discharge them, the less number of cycles of charge and discharge the batteries can handle. And so by trying to minimize that percent discharge, it allows us to maintain our batteries to best. Batteries are expensive, batteries are heavy, and we try to take as much care of them as we can. The other ways that you can care for the batteries is trying to use the power that you generate at the same time that it's being generated. And so if you have something like if you're trying to run equipment for a school or water treatment, doing it when you have the most amount of sun minimizes the impact on the battery. So batteries are important. It's pretty difficult to have a solar system that functions without some type of battery storage, because the output of the solar panels can vary just with cloud cover as well as time of day, and you want to be able to power your system even when the sun goes down. Once again, PV stands for photovoltaic, and it's another word for solar. And so batteries are able to provide energy when the solar panels aren't meeting our current demand. And we use deep discharge batteries similar to those that are used in forklifts or golf carts, similar to what might be in your RV as well, or your travel trailer, to power that system too. So these are just a couple of models that we use often. So I said that everything we've talked up to this point has been DC power, and but most of the equipment that people have in hospitals or schools or even in our home often runs on the AC, and so we need a way to convert that energy. And so by doing that, we use an inverter. These are two models of inverters that we use, and basically coming out of that is just like plugging into your outlet at home, and it gives us the ability to use existing equipment, and it also gives us a little more flexibility on wiring and that type of thing. We can have DC loads as well. There are DC light bulbs and even LED bulbs and compact fluorescent bulbs that we can use. And there are some advantages to doing that, because the inverter itself uses some power and loses some energy in the form of heat when it makes the transformation from DC to AC. And so one of the things we talk about, and that I'll demonstrate a little bit later, is the difference in how much power we need if we try to power something through an inverter versus just doing it through DC. So we talked a little bit about loads. Loads are just what we're trying to use the energy for. And a water system is a good example because it uses both DC and AC loads. Our Solar Under the Sun started as an offshoot of Living Waters for the World. And so many of our early systems powered water treatment systems. And so here you see that coming from our load center, we have a disinfection inverter, which will power either an ultraviolet disinfection or an ozone generator. These are difficult to find in DC versions, and they're more expensive, and so it's cheaper to use a small inverter to power those. However, for our board pump, what we had found is that DC pumps are much more efficient than AC pumps, and so it costs more to get a DC pump, but by making that transition, we save energy, as well as we don't have to buy a great big inverter. Saving to buy the inverter basically makes up for the cost of the DC pump and helps us there. And we use a special kind of switch when we try to turn on and off high current DC loads, and that's this fast acting switch here. I know I'm kind of going through a lot of this pretty quick, and I do want to reassure you that every single piece of equipment that I've talked about to this point, we have our entire lecture on, and then the chance to actually hook it up. And speaking of that, this is a few pictures of our hands-on exercise. We break up in groups of between 3 and 5, and each of those groups will build a system. Usually we have 2 or 3 groups that will do a 12-volt family size system, and then 2 or 3 groups that will do a community size system. And the concepts between both of those systems are exactly the same. The components are their functions are very similar, and their connections are very similar. And so we encourage people to kind of watch as what other groups are doing, so that you get a little bit of experience in both systems, so you're only able to do the hands-on for one system. And so here they're wiring up a 12-volt system, and we have their charge controller here and their load center. This is their interface box, and then this is their inverter up here. And this is another group that's working on our community scale system. The same components again. We have here our DC load center. We've got our charge controller, and then we actually use some pigtails to connect to another inverter, as well as to our power supply. And this is that fast acting switch that you saw connected to the board pump. And so at the end of the day, we need to know the way to do that is what we call the smoke test. And here you see one of our instructors kind of looming off in the distance, not getting too close. But they passed their smoke test here, and their lights came on. And so we know that all the wiring is correct. One of the most important lectures that we do and processes that we do, we call the last thing you do before turning on the system. And it's a checklist of all the things that you need to look at before you put power to it, so we don't damage any equipment. And so far, we haven't had any smoke. And so here you can see a community scale system that's been connected. And once again, they have their inverter here, charge controller, battery monitor, their DC load center, the fast section, and then their load is the light bulb there. And so a job well done to them. So I wanted to talk, we've talked a little bit about in the previous lectures about the solar site survey and how important that was. And typically that's done during that first trip of our 3-trip model. And the end result of the solar site survey, in addition to developing those relationships and figuring out your suppliers and making the plan for the trip, is that you have the needs, the electrical needs that they have. And so what we need to do is use that to develop the system that they need. Do they need a community scale system? Do they need a family scale system? Are they going to be powering computers or lights or fans or anything else? And so how do you know how to make that conversion? And what we do is we use something called the electrical needs analysis spreadsheet. When I went through solar school, in the first solar school, it was about 13 pages, handwritten with all calculations on your calculator. But now it's a simple spreadsheet. And so I wanted to kind of go through a little bit of what it would be to use this. And so we supply an Excel spreadsheet, and the only numbers that you have to enter are the ones here in the pink. And so we watt. If you have a 40-watt light bulb, then device watts is 40. If you have a 17-watt CFL, then device watts is 17. We need to know whether we're going to run it on AC or DC. The reason we need to know that is because if it's going on AC, then we have to have an inverter, and that inverter loses some power. And so it will take more power to run an AC 17-watt light bulb than it will a DC, because the inverter uses and loses some of that energy. We need to know how long it's going to be on. So how many hours a day and how many days per week, and then how many light bulbs are there going to be. And so in this particular question, it says one 17-watt CFL, which is equivalent to a 75-watt regular incandescent, is going to be on for 8 hours a day, 7 days a week. And so we put in those numbers here, and then the yellow values are the calculated values. And so the spreadsheet automatically comes up with these numbers. And so it's going to use 952 watt hours. If you look at your electric bill, then what you'll see is kilowatt hours or 1,000 watt hours. And so this is going to use almost 1 kilowatt hour. And then it automatically calculates how many watts of solar panels that's going to take. And so in this particular example, it's going to take 54 PV watts or solar watts that we need to run that one device. If we do the exact same light bulb but in DC, so we'd have to buy a DC light bulb, which may cost a little bit more, but you can see we would only need 43 PV watts to add to the system. And while one light bulb might not make a big difference, if you're using a lot of light bulbs, then the difference in how many solar watts you would need can really add up. All right. So I'm going to stop here for just a second, and I'm going to open us up to, I've been going fairly quickly, I know. And part of it is because we don't know exactly what everybody is wanting to get out of this. So I think the most important part of this is to realize that that this is an introduction to what we would teach in Solar 2, and realize that there's a lot more information out. People go ahead and enable their video if they want to. And I'd also like to know if anybody has any questions that we could answer. I have several other solar instructors on here with us, and so I may defer to them to answer questions. You can type your question in the chat if you'd like, or if you raise your hand just like this, or use the raise hand button, then we can acknowledge you and unmute you as well. I would like to try to keep the questions a little bit generic so that
you all should be able to unmute yourselves at this point, I think.
All right.
Can you unmute yourselves?
Does anybody have a question? Elizabeth says you should be able to unmute yourself.
Did it work?
Go ahead, Billy, or Patrick, right?
Yeah.
Yes.
That's right.
All right.
She's the boss. That's why her picture's up.
I understand.
You brought up something that surprised me. You said standalone systems. I hadn't really thought of what that means, but what it, I guess, means is that it's not hooked up to a major power source.
That's correct.
And you avoid that because of the complications?
Well, there is a lot of extra problems that can develop when you combine another power source, such as a generator or grid power, and that can get fairly complicated. The biggest thing, I think, has to do, one, with safety, but also it's very difficult to know exactly how all the grounding for those work, because there are just so many different situations. And so yes, we don't teach that for those particular reasons. There have been some cases where what we've done is run parallel systems, but not connected. And so I had one situation in Sierra Leone where what we did was, on the outside of the building, we had a big knife switch that we could either connect just our solar system, or we could connect just the generator, but never were those two connected.
Yeah, it was fail-safe then. Somebody didn't turn something on but forgot to turn something off.
Right.
So
it made it impossible to connect that.
Right.
Dave, do you have something to add to that?
Yeah, when I get unmuted here. What we did from the get-go with this was to say that in a 3-day school, with all the different possibilities that you can run into out in the real world as to how different other voltages could come into the system, we just couldn't cover that so that people could go out and safely work with that. So from a safety point of view, we said we're going to teach a standalone system. If someone goes in country and they have a high quality electrician there that understands the local system, and secondly, we have confidence in them, and our own team members have enough confidence in their own skill, then I would say maybe they could try to tie it together. But we are not going to teach how to do that, because there are so many ways that smoke test on that system is going to be a lot of smoke. And so we didn't want to get people hurt. So we just said, we're not going to teach that. And we still don't.
Well, that's good to know because now I know what to avoid.
Well, yes.
Okay, no, it's good to know.
We found it is just in the things where we have been working with local power grids. The grids can be themselves very unstable and would not meet standards at all for what we deal with here in the United States. And the differences in what comes through those power lines in terms of grounding, neutrals, and all of that sort of stuff, and is AC. It's just too complicated for somebody that really doesn't work with it all the time to really figure out how to work with it safely. So we don't.
Okay, that's good to know. That's good to know.
I think Lee was raising his hand down here.
Thank you. Could you give us an idea of the cost, the stateside cost of a system to run like an LWW water plant, and then also the cost that your household systems, entail, each household?
Dan, do you have a guess number for a living water system?
I will give you a round number. The actual equipment, the power equipment, not the houses or anything like that, is something in the $3,000 to $5,000 range for a 24-volt system that will run a water system. That's the pump. That's what Walden showed you on that block diagram. And then I say that because it depends on how much other community supply that you're going to have to do will drive the cost up or down. So I would cap it between 3 and 5 generally. And the at home, the 12-volt system, which has a 300-watt AC inverter, and we try to run DC lights on that one to not lose the efficiency of the inverter, is right at $1,000, somewhere between $800 and $1,000. And that includes everything we do. That includes lights, fixtures, wiring, panels, battery. In that case, we use a single battery. So if that satisfy your question?
Yeah, I wasn't on the LWW system. Is that the 3,000 to 5,000 figure? Is that for just the solar end of it? And I think you said the DC pump is included in that.
Actually, at the $5,000 level, the water system itself that we purchased is about $3,000. So the 5,000, if you want to get the water system, you probably go up to about 6,000. So you're in the $5,000 to $6,000 range to actually get the water system. Again, you really need to come to school to learn a lot about this. But first of all, a lot of this is in the handbook. But second of all, we talked about it. For example, what's your water source? Do you have to have some kind of submersible pump to get the unfiltered water to your processing location? Because the pump that Rollins showed you simply circulates unfiltered water up to make clean water. It doesn't pump. It doesn't pump from a well. You have to gravity feed that pump in order to clean the water. So if you need a submersible pump, that's a little bit more, but it's not a huge amount more because we work a low volume submersible, or we recommend a low volume submersible pump that runs off 24 volts.
Okay, thank you.
Any
I
other
wanted to thank-
questions?
I wanted to thank you, Roland, for the letter you sent me.
You're welcome.
I took your advice and called up some major solar companies, Canadian Solar, Enphase, Astro Energy, and I couldn't find anything that served Africa. Maybe you have suggestions on companies that are reputable that are in Africa?
The only one I know of is in, like I said, in Sierra Leone. The company was called Aptech, APTECH. It's actually a British parent company or a UK parent company, and I know they have several different countries that they work in. And I don't know whether there's anything reasonably close to Ghana or that might be worth looking into there. And I found that group through an internet search. But I think what you want to look for is trying to find a company that has brand name equipment. They're not selling Chinese knockoffs of things. You want something that you can get in other places and are semi-reliable. So that'd be my suggestion then.
Roland,
And
may
I
comment?
would, yeah. And then Lee's got a question again.
Okay.
So we work in Honduras, and I'm just curious, are PV panels available in country, or there are large bulky things? What is the shipping recommendations that if you need to ship?
So for all of our systems, we generally recommend buying the solar panels and the batteries in the country that you're serving. And almost every third world country, the rich people have solar. And so it's there. You just have to figure out where it is. And you might not always have the same manufacturer, so you have to work within the constraints of what's available. But we've been very successful at finding solar panels and batteries. And Megan has done multiple trips to Honduras, and they've done the family scale system primarily, but have done community scale as well. And we've had a couple of Eco Scouts that have put those small systems into small schools, and so it's not necessarily that you can't run anything else off of it, but that's one of the things that we teach is trying to figure out how to size your system to make sure you're only paying for what you need. And most of our other equipment we end up carrying. Did you have a comment?
Was that to me?
Yes.
I'm sorry. Okay. Your sound cut out, at least for me here for a moment. Lee, you did say Honduras. If so, shake your head yes.
Yes.
Okay. I know that Megan is going to know some suppliers in country. And when I was putting the two 24-volt systems in, we had a very good supplier we found in San Pedro Sula, up at the northern end of the country. It's a subsidiary of an American-based company, but he's working in third world locations. And as far as if they're still there, they're a very good source for panels and batteries. They've got good quality, very good quality panels, and they've got Trojan batteries.
Dave, if you don't mind, that company is, I think you're talking about is Soluz.
Yes.
SOLUZ, and they're pretty widespread in Honduras, and that's where we usually get panels, batteries, and light bulbs. They've got all kinds of other equipment and things like that. And then there's multiple, both in Tegucigalpa and in San Pedro Sula, there's multiple electrical companies there. If you need to find, smaller parts or wire and, disconnect boxes. And
It's Home Depot South, so, it's good to go. No, there are good suppliers there. And then Billy, I looked online at the largest city in Ghana, and there are, just on the internet, I found 12 different solar suppliers in that city. And so what I would do is just start looking at their sites. And when after going to solar school, what the good brands are, I mentioned Trojan batteries, for instance. If a place has got a Trojan battery and it's really a Trojan battery, it's going to be the battery you want. There are a couple of other brands that are good too. There are some things that come out of China that are excellent. There are some things that come out of China that is junk. You have to know which one you're looking at. We have some very good stuff that's come out of China that's being used in parts of Africa. There's some other stuff that's come out of China that's not good. So you have to know what you're looking at. And I don't know how to tell you to learn that other than look at it and talk with people on the field to see if it's working for them or not. But there are a number of suppliers in, what is the largest city? It's there on the coast. It starts with an A.
Oh,
Ghana.
I know, Attica or something like that.
Yeah.
I can't think of the name.
don't
So
know.
just go online and say Ghana.
I just went online. I said solar suppliers in
companies.
Ghana. I said solar
Ghana,
suppliers in Ghana, and I hit 12 there, and there's a couple of others in some of the other smaller cities around the country. What Roland said is proved out every time. No matter where you go in the world, there are rich people that want power, and if they can't get it in other ways, they get it with solar, and there are going to be people that will meet that demand. If we can get solar equipment in Haiti, we can get solar equipment anywhere in the world.
Okay, all right,
Right.
I'll work at that. Thank you.
Another comment on other countries, especially Honduras, we have 2 people that are Hondurans that we work with extensively. And we'll be happy to share those names with you. And they are well trained. One of them has actually been to solar school here in the States. And
Yeah, I know Olvin Duron very well.
yes, and he is sharp if he's not in seminary. I don't know whether he's still working up for Living Waters or not, but
Oh, he's one of our
don't
main.
have anybody in Ghana. But if you want to go to Haiti, we could recommend some really good people there as well.
Go ahead, Lee.
So I'm curious, do you end up using mostly 6-volt batteries or 12-volt batteries?
Yes.
It all depends on what we can get.
Oh, really? What would you prefer?
Yeah.
What would you-
Roland just
Mo-
used my
mo-
line. Roland just used my
mo-
line. He said it depends.
Right. Most of the time with our 24-volt systems, we end up using 6-volt batteries. And with our 12-volt systems, we use a single 12-volt battery.
Okay, and always deep cycle.
Yeah.
Have you ever had to run with a automobile battery?
I
No.
haven't.
Okay.
No.
All right, Jenny has a question for everybody. She said, is this
Yeah,
what,
go ahead.
she said, is this what the
Oh.
Solar 2 trained leaders are responsible for, securing the materials and supplies for the project?
Exactly. Yeah. And so that's part of our training as well is we talk a lot about where do you get each component. We've got parts lists that give you an idea of what you're looking for, and then being able to identify what do I need to buy here and carry down, or what do during the survey trip, that first trip is when you try to identify those vendors as to what equipment you can get there, so that you're not having to carry it and you're supporting the local economy. So we try to encourage both But it's very difficult sometimes to find the equipment you're familiar with, especially when it comes to charge controllers or that type of thing. And so we end up carrying those down. All of the instructors are very giving of their time and willing to help. And so as you learn, then we're always available for questions. If you ask 6 different solar instructors the same question, it's just like asking a doctor. You're going to get 6 different answers. But there'll all be versions of the truth. And so I tend to, I'm not an electrical engineer, and so I'll give you the pragmatic truth, and whether or not that the most or the best truth is up for debate, I think. Patrick, did you have another comment or question?
Yes, an idea of how many suitcases, if the panels and the batteries are local, that you would need to take everything else. And I'd imagine that it doesn't matter whether it's 1 or 2 panels that you're using or 20, because the equipment's going to be pretty much the same, right?
Well, we don't typically go up to most of our systems, what we teach goes up to 6 panels.
Okay.
And so most of the time our teams are anywhere from 5 to 8 people maybe. And what I usually say is that 1 suitcase of your checked baggage is mine to put our stuff in, and then part of your other one perhaps. And so does that sound about right, Megan?
So you're talking like
yes
6
or no?
to 8 suitcases?
Sometimes.
You're talking, oh, really? 6 to 8 suitcases?
Yeah.
Okay.
I-
Okay, well, I need to know that.
I would say it really depends on how much you can find in country too. Like if you're trying to
Yeah.
bring wire with you, that's going to take a lot more space. If you can get all your wire there, you're going to be, much smaller.
Yeah, everything will save a suitcase.
Yep.
Yeah, because
Yeah.
there's probably a total of 5 people going, but they've all got other projects too. So mine doesn't necessarily get all the suitcases, even if we take 2 apiece, or sometimes it's 3.
Right.
Okay.
But
Okay.
I
Thank
think
you.
a 24-volt system can go into a few, especially if you're not having to bring a lot of the wire, if you're just bringing your charge controller and your DC load center
The
and
tools
that kind of
and-
stuff.
Tools, yeah.
Yeah, again, it
Yeah.
depends on how many tools you're having to bring. If you're having to bring all your own
Right.
drills.
Do you have to drill through concrete, things like that?
Right.
Yeah.
Yeah.
And sometimes
Okay.
weight is a bigger driver than size too. So.
Okay. Okay, just an idea. Thank you.
Jenny, did we answer your question enough?
Yes, you did. Thank you.
Okay, good.
Let me make a comment, and I want to comment about one of our other instructors, a guy named Dan Daniel, who makes the most meticulous packing lists I've ever seen in the universe. And he can tell you to the ounce the weight of every item that he's taking with him, and he can divide it up 32 different ways to go to in 16 different suitcases so that everybody has an equal load that they have to carry. Now, Dan is way too meticulous for me. I throw it in the floor, I pick it up, you take this, you take that, you take that, and we're out of here. But
Here.
if you really want to know what it's going to take, get Dan off in the corner sometime and talk about his
Okay.
spreadsheets of packing lists. There is
Okay.
lots of experience there.
And his buy lists spreadsheets as well, because you have every nut and bolt, and not only that, how much it costs, but what aisle you can find it on in Home Depot. So
Exactly.
it's good stuff. It is vital stuff. So
Dan, are you blushing yet?
Yep.
We have a
That's
couple of
good.
people, we have a couple of people on cell phones. They may want to ask a question if they can unmute themselves. David Edwards, you got any questions?
Well, David knows it all. He doesn't need any questions.
He's done this.
Almost teach it.
Might just be hanging out, soaking it all in. Or texting Rollin, telling him what to say. Either way.
I just messaged him and asked him if this was the David that I went to Haiti with and that danced with Ruthie.
It's the same one.
All
Yes,
right.
I thought it probably would be. There can only be so many.
There's
Patrick,
only
I would be
one-
more than happy to talk with you either through Zoom or on the phone sometime about what you got going on and see if there's any other questions I can answer. When dealing with solar companies in Africa, what I found is that you'll find kind of three levels. There's some will be primarily looking at installing big, huge systems. And they won't want to mess with you because you're too small, you're too small. And then there's going to be little ones that don't know what they're doing. And so you got to find, the porridge that's just right. And if you can do that, then I think they can be helpful. And what I did was I emailed several of them in Sierra Leone with just a little introduction of, hey, I'm doing this. Is this something that you can help me with, or can you tell me, they may be able to lead you in the right direction as well. But most of them will have a contact.
Okay.
All right.
Oh,
Yeah, go ahead, Jenny.
I just realized that I don't know a lot about what happens on the country's end before a project starts to form. How does Solar Under the Sun determine where there's a need, or is there some sort of like application process that happens? Can you talk a little bit about that?
I'll talk about it unless Megan wants to.
go ahead.
Okay, so this is what I would say. Most of our systems, or many of our systems, started out with churches that already had, or organizations that already had some connection to another place. So whether it's a church that was supporting a school or an orphanage or that type of thing. And then often once one person gets electricity, then other people hear about it, and so we learn more and more needs. And so you almost can't go to Haiti without finding somebody else that wants you to come look at their place and see if you could do something. And so often we have areas that, if you've got people that are looking to serve and want to do something, then we may be able to help connect you with communities in need, whether that be schools or churches or orphanages or whatever. And then otherwise, some of our systems, like our Honduras program, where we're doing the systems in houses, that was initiated through Solar Under the Sun, and it was primarily started as a way to help people get a little boots on the ground experience after they've gone to solar school, so that you don't feel overwhelmed with that first trip. you know, because it's pretty scary to go to 3-day class and then be expected to, you know, collect all the right equipment and go to some other country and do all this stuff. And so, so that's we call that Solar Direct. And so that's what Megan has done a lot of in Honduras. And so does that, Megan, do you have something to add to that?
I would just, go ahead, Chris.
I'd like to say that in the countries that we're already operating in, there's plenty of opportunity that we can match you up with if you wanted to find your own particular program. But once you get established in a country, you won't find any lack of opportunity once you make a beachhead there, because they'll just pop up everywhere you go. Believe me, there's lots of need out there, and you'll find it. You'll be overwhelmed by it, as a matter of fact.
And I would just add that if anybody knows of communities in need in other places, especially places that, you know, we don't, aren't aware of that need yet, or don't have a contact there yet, they can always email Solar Under the Sun or get in touch with Solar Under the Sun. We like to try and maintain a list of people who are interested in partnering with somebody in the US. So if we have people who come to Solar School and say, hey, I'm interested in doing this work, but I don't have a project, we can try and help make that connection as well. So we don't have a formal application, but we do encourage, if there's, you know, people that know about a community that would benefit from this kind of system and is interested in trying to get a partnership going with the church here in the US, let us know, and we will keep them on our radar and on a list, so that if we do have people looking for projects, we have something we can connect them with.
Mm-hmm.
I'd say another good way to find opportunities is if after you go to Solar School, you can, you know, sometimes you meet people in Solar School that you can network with. A lot of my trips have been, you know, with other groups, and so especially for your first trip for solar, going with another group that already has a little bit of experience both gives you experience in going and seeing how that trip runs, but it also gives you kind of a foot in the door in that country where you can meet and see opportunities there as well. So you could be that next step from where they're serving. You can be that next step over.
Guys, we've reached 7:30. Does anybody have any more questions or comments? Obviously, we're happy to stay later, but I just want to respect everybody's time tonight. So, all right, well, a huge thank you to Rollin for leading this conversation, and a thank you to everyone for being here. We're going to have this video up on YouTube, and I'll go ahead and send out that email with this link along with the other 2 webinar videos. So if they have been helpful for you, please feel free to share them with your churches and your organizations and your friends and your family. And I hope that whenever we are able to schedule our next Solar School, you will keep that on your mind and get that registration form in, because we would love to have you. So thank you all so very much. And if you need anything,
Thank you.
it's info@solarunderthesun.org. Thanks, guys.
Okay. Thank you.
Thanks.